In today's lecture, we're going to take our first look at the chain rule. Now, the way I structured my derivative rules and the derivative rules plus, I've actually already incorporated the chain rule into some of the rules that we've already introduced. So you've been using the chain rule all along. So let's take a look at the derivative rules without the chain rule and then the derivative rules plus with the chain rule. So the first one was that the derivative of x to the n was nx to the n minus 1. Then we had the derivative of sine of x is equal to cosine of x. The derivative of cosine of x is minus sine of x. The derivative of e to the x is equal to e to the x, and the derivative of ln of x is equal to 1 over x. So these were the 5 basic derivative rules. Now the 5 basic derivatives plus, or the 5 basic derivative rules with the chain rule built in, were as follows. The derivative of u of x to the n is equal to n times u of x to the n minus 1 times u prime of x. The derivative of sine of u of x was cosine of u of x, and then times u prime of x. The derivative of cosine of u of x was minus sine of u of x. The derivative of e to the u of x was just equal to e to the u of x times u prime of x. And then finally the derivative of the ln of u of x was equal to u prime of x over u of x. So these were the derivative rules with the chain rule. And then these were just the basic derivative rules by themselves. So what's going on here? So when we look at the derivative rules and then the derivative rules with the chain rule applied, how do we go from the column on the left to the column on the right? The column on the left, our variable x, is replaced with some more general function u of x. So instead of just x cubed, we have some function of x cubed. Instead of just sine of x, we have some sine of some function of x. Instead of e to the x, we have the exponent of some function of x. So just the simple variable x is being replaced by a more complicated function. And when we take the derivative in each case, we basically do the exact same thing. So here I have sine, and this is u of x. So sine of u of x. So basically, however complicated whatever the inside argument is, or the inside function, u of x, we basically just see this as sine of u, and the derivative of that with respect to u is cosine of u. So the sine of u becomes cosine of u, just like the sine of x becomes cosine of x. But that's not the end of the story, because we really want the derivative with respect to x. This is just the derivative with respect to u, so then we multiply by the derivative of u with respect to x. So we have to throw in that du dx. So notice each of these 5 extended derivative rules, the x was replaced with u of x, and then basically the rule was exactly the same, except then once we applied it, we had to multiply by u prime of x. So one way to write this is if we have y is equal to f of u of x, dy dx is, we can think of this as df du times du dx. Right? So that's one way of looking at the chain rule. Let's see an example of that. So suppose we have f of x is equal to let's do something else. Something that's obvious when we take the derivative of it. How about sine of 3x squared plus 7? And actually let me call this y, because I did use f up there, so let me just say this is y is equal to this. So there's our function y, which is a function of x. Now we have to break this up into an outer function and an inner function. So there's an f of u and a u of x. So the u of x is always closest to the inside. So in this case, our u of x is exactly the stuff that we're taking the sine of. So we would say that the function u of x is equal to 3x squared plus 7. So then the sine of u, or rather f of u, would just equal the function sine of u. Right, so when I replace u with u of x, I get my original function sine of 3x squared plus 7. So that's kind of how this works. So we're basically replacing that inside function with just a single variable u. So instead of sine of 3x squared plus 7, we have sine of u, and then we understand that u is equal to u of x. So the rule says that dy dx is df du times du dx. Well, df du, sine of u, the derivative is cosine of u, and then du dx is going to be the derivative of 3x squared plus 7, so du dx is just 6x. So it's cosine of u times 6x, and then of course we want to plug back in u of x, so it's cosine of 3x squared plus 7, and then times 6x. So basically, this first term is the derivative of the function with respect to u, and u is basically just the blob where we take the entire inside function and we put a blob around it. So it's just the derivative of sine of blob with respect to blob, or the derivative of sine of u with respect to u. And then the inside function, which is u of x, we have to multiply by the derivative. So this one is du dx. And the whole thing is basically dy dx, or I suppose you could also call it df dx. But I'll stick with dy dx so we don't confuse the different functions. So it's basically, I mean, you could say this is df dx. You know, we can say basically y is equal to f of u of x. So df dx, we have to get to, in order to get to df dx, we have to go through u. So df dx is df du du dx. So you can think of it like that as well. So df dx you can think of as df du times du dx. Right, so to get to that inner variable, you have to basically create a chain. And it makes sense intuitively, well, the small du should cancel, so we should end up with df dx. Another way of writing all of this, and perhaps slightly more formula, so if we have y is equal to f of u of x, we can say that dy dx is equal to f prime of u of x times u prime of x. So we're pretty much doing the exact same thing, only slightly more explicitly. So the first term is really our df du, and then the second term is still du dx. So it's still that same structure of df du times du dx, except here we're representing df du as f prime of u of x. So one thing to note is that based on where this prime is, it's really a derivative of the function f. So it's ignoring the fact that the input is itself a function of x. So this derivative basically sees f as just a function of whatever you want to call it a function of u, and it's taking df du. So let's go back to our example. If we have y is equal to sine of 3x squared plus 7, so here again, f of u was just sine of u, and then u of x was 3x squared plus 7. So of course, f of u of x, well, f of u of x is taking the input u of x, right? So basically the 3x squared plus 7 is being inserted for u. So f of u of x is just f, the function f, with the u's replaced with u of x. So it's sine of 3x squared plus 7. But the function f itself is just sine of the input. So f of u is just equal to sine of u. So from this, we would say, well, f prime of u is going to be cosine of u. And then from u of x, we see that u prime of x is just equal to 6x. So if we write f prime evaluated at u of x times u prime of x, well, f prime of u is cosine of u. F prime of u of x would be cosine of 3x squared plus 7, and then multiply it by u prime of x, which is 6x. So this one right here is basically u of x. And then this is u prime of x, and this whole thing is just f prime of u evaluated at u of x. So it's f prime of u of x. So we're taking the function u of x and plugging it into f prime. Right, so that's basically how the formalism of the chain rule works. Let's do another example so we can see this in action again. So let's say we have y is equal to sine of x plus cosine of x to the 7th. Right, so this is a little bit less obvious what the inside and the outside functions are, because we had sine of 3x squared plus 7. It was quite clear that 3x squared plus 7 was inside. Here the inside is exactly everything in this square bracket, so it's sine of x plus cosine of x. So our inside function is really right here, so that's all u of x. And so this function is basically u of x to the power 7. So f of u is just equal to u to the power 7. And then u of x is the inside stuff, sine of x plus cosine of x. Right? So then when we compose the two, f of u of x, we take u of x and we plug it in for u in the function f. So f of u of x, we basically just take u of x and plug it into u. So f of u was just u to the power 7. Right? So this is all u and to the power 7. So u caret 7. Now f of u of x, we have to replace the u with u of x. So u of x comes right in here, sine of x plus cosine of x. So that part there is u of x. So it's u of x. So we see that f of u of x does work out to be sine of x plus cosine of x, all raised to the 7th power. Now to compute the derivative, the chain rule says that dy dx is equal to f prime evaluated at u of x, and then times u prime at x. Well, f of u was u to the 7, and u to the x was sine of x plus cosine of x. So based on that, f prime of u is just going to be 7u to the 6th. And u prime of x, well, derivative of sine is cosine, and the derivative of cosine is minus sine. So it's cosine of x minus sine of x. So to find the derivative of our original function up here, it's literally just f prime evaluated at u of x. So let's write our final answer, dy dx. So it's f prime evaluated at u of x. So we take this u and replace it with sine of x plus cosine of x. So we get 7 times u of x, sine of x plus cosine of x to the 6th power, and then times the derivative du dx. So times cosine of x minus sine of x. So this is the derivative of sine of x plus cosine of x to the power 7. In other words, the 7 comes down, you treat the inside as just one blob, you get 7 times blob to the 6th, and then we just multiply it by the derivative of the inside. So that exactly is the chain rule.